Thank you for coming. My name is Danny Rowan Hawk, pronouns they, them. I'm a math specialist here at the Learning Commons, and I'm doing the MAC 1105 Test 3 review. I'm aware that there's some classes that are at different pacing schedules. Some classes are just taking Test 2, and while others are taking Test 3. If you're looking for Test 2, that has already been done, recorded, and sent to your TCC email, so you'll want to be sure to look for it there. This will also be recorded and sent to your TCC email, and there will be another Test 3 review in mid-November. So let's go ahead and get started. Okay, so for this this third test, there's various stuff from solving different types of quadratic equations, absolute values, as well as a couple word problems. And I think that's about it. Oh, and inequalities. So that's what we'll be going over today. So if we're looking at this first one and we want to find the exact solutions, how would we go about this for 6x squared minus 36 equals 0? And you can unmute it this time.
We wouldn't do plus 36, right? No.
So that is something you could do. You could do it that way. I would suggest rather, because there's a greatest common factor, I would look at that first. But if we do, let's do plus 36. I like that idea. Okay, so then you have 6x squared equals 36. Now what?
Do we have to divide now?
Absolutely. Yeah, we'll divide both sides by 6 because remember, it's really important for us to get that x squared by itself. So now we have x squared equals what? What's 36 divided by 6?
6.
Yep. Sorry. All right, and now this x is squared, but we want just x. So what's the opposite of squaring something? What would we do to make this x squared just x? Good job. Someone messaged to square root it. Absolutely. The opposite of squaring something is square rooting. So if we take the square root of both sides, this becomes x. And because we personally square rooted something, how many answers do we have? Do we have one answer or do we have 2? Yeah, we have 2. We get plus or minus the square root of 6. If you're entering it online, then you would want to separate it as x equals the square root of 6 and negative square root of 6. Good job. How about x squared plus 4 equals 0? How do we want to handle that one?
Can we do it the same way or?
Absolutely. Yeah, no, absolutely. This is think of it as extraction of roots. So we're absolutely doing it the same way. We're getting the x squared on one side, and then what's our next step here? Same thing, right?
Yes, divide it. Oh no.
Square root, right? There's nothing to divide. We already have x squared by itself, so we're already at this step right here.
Oh, okay.
So this becomes x, but what is the square root of -4?
Be 2, -2, 2.
Ooh, careful. Is a negative square root a real number?
No.
No, it's not. So remember, when you're taking the square root of a negative number, think of it as you're taking the square root of that number times the square root of -1. What's another way to write the square root of -1? You might have heard the word complex or imaginary. So what is the square root of -1? Yeah, it's I. The square root of -1 is I. So what's the square root of 4? And I think someone said earlier. Any takers?
It'd be 2i.
Yep, you got it. Be 2i. And again, and this, what's really important for this is you're only worried about this if it asks for all solutions, right? Real and complex. If it only wants real solutions, so if only real solutions are wanted, it's D and E, right? But if we want all solutions, then we have a -2i and 2i. Does that make sense? Okay, any questions on this? We got 2 more that we're gonna solve for. Okay, and then another term for this is extracting roots. All right, so how about here? So here we have 2 quadratic equations. How do we want to solve these? Can we factor them? If we take a look at this first one, x squared minus 5x plus 3 equals 0. Can we factor that?
No.
No, we can't. Because the factors of 3 are 3 and 1, but 3 and 1 don't add up to 5. So what do we have to do if we can't factor it all nice and neat? What do we use? What formula? Yes, good job, Cadence. Quadratic formula. Yeah. So we're going to use that x equals -b plus or minus the square root not a 4 squared. Let me try that again. Oops. Yeah, there we go. B squared minus 4ac all over 2a. Okay. So in this one, what are our A, B, and C? What's our A? 1. Good job. And our B?
Would it be 5?
Very close. -5. Don't forget that the this right here is attached to that. And our C? 3. Good job. Whoops. Did not mean to hit that button. Okay. So now it's just a matter of plugging it in. Plugging everything in where it goes. So we have -5. See that for our B? Plus or minus the square root of -5 squared. Make sure whenever you're plugging a number in, you are putting it in parentheses. Notice everything I've plugged in is in parentheses, especially with negative numbers, because it's very easy to get it messed up, especially if you're typing it in a calculator. Okay. So let's clean this up a bit. What's -5? Yep, 5. Okay. So we have 5 plus or minus -5 squared. -25. And then we're subtracting 4 times 1 times 3. 4 times 1 is 4. 4 times 3 is what? 12. Good job. And this is all over 2 times 3, which is 6. Okay. Oh, I messed this up, didn't I? And no one caught me on it. This shouldn't be a 2 times 3, should it? This should be a 2 times 1. Because that's an A. There we go. All right. Cleaning this up a little bit more. 25 minus 12 is what?
13.
13. And can we take the square root of 13? Is that there's no way to really reduce that radical? It's prime. So this would be your answer. You could write it a couple ways. You could write it as 5 halves plus square root of 13 halves and 5 halves minus square root of 13 halves. Or should put an or there. You can write it as 5 plus square root of 13 over 2, 5 minus square root of 13 over 2. So both of these are correct and should get you the right answer. All right, taking a look at the second one. Let's go ahead and use quadratic formula again for this one, right? Same thing. It's going to be really difficult to factor. So we have A, B, and C. And our A is what this time? 2. And our B?
-3.
You got it. And our C?
4.
All right, so let's set it up. So we have x equals -3 plus or minus the square root. Again, everything in parentheses. And then our a is 2, and our c is 4. And this is all over. I should try and draw a straighter line than that. Well, I tried. 2 times a, which is 2 this time. Okay, so just like the -5 was 5, -3 is 3, plus or minus. And what's -3 squared? Nine. Good job. And this time we have 4 times 2 times 4. So we have 4 times 2 times 4. What is that? 4 times 2 times 4.
32.
Yeah, 32. Okay. And this is all over 2 times 2, which is 4. All right. Simplifying it a little bit more. What is 9 minus 32?
-23.
-23. Now, remember, this is the square root of -23. So what does that negative do? What do we turn that into? How do we write this properly?
We turn it into a positive.
So when we have the square root of -23, remember that that is the square root of -1 times the square root of 23, right? And what did we say square root of -1 was?
I.
So this is the same thing as I times the square root of 23. And that's how you would reduce that properly, or simplify it, I should say. 23 is a prime number, can't really do anything with that. So this would be your answer. And again, if you're filling it out online, it would be 3 plus I root 23 over 4, 3 minus I root 23 over 4. Any questions on that one?
I have a question. So when we put the answer in, it would be both of those two at the bottom?
Correct, because remember, this plus or minus means that there's 2 possibilities.
Oh, okay.
So it's just separating it into the plus and the minus. Good question, though. Feeling pretty good about this one?
Yes.
All right, let's move on. Okay, now we're dealing with some absolute value inequalities. And there are some rules to these. So what is the rule with absolute values when we go to solve them? How many equations do we end up with? Yes, absolutely. We end up with 2. Okay, and so let me go ahead and bring this up. And when it's a less than, there's a couple ways you can write it, because you have it as x plus 3 is less than 4, And since it's a less than, it's also, and it's greater than -4. So you can write it like that, or you can write it as x plus 3 is greater than -4, and x plus 3 is less than 4. This being the original and this being the other possibility. And again, that's only because absolute value is a distance from 0, and distance from 0 is always positive, even if we're talking about a negative number and a positive number. Okay, so if we're solving this inequality and we need to get x by itself, what do we do with that 3?
But we subtracted 3.
We would, and the key here is if you subtract 3 from one side, you subtract 3 from all sides. So that gets rid of that. So we only have an x in the middle, and we can bring this down. What's -4 minus 3?
It would be 7, positive 7,
Not positive.
negative.
There you go. Good job. And then we have 4 minus 3, which is what?
1.
1. So we have that x is between -7 and 1. A really good way to see that, sorry for my non-straight line. I wonder if, nope, I have no possibility to draw a straight line here, guys, sorry. So the way this works is, and if you'd separated it like we had before, you would have had, x is greater than -7 and x is less than 1. So if it's less than, does it include that number or does it not include that number? Would this be a closed circle or an open circle? Open.
Open.
Good job. So we have open circles, and for this one we have x is greater than, okay, so we know that that goes that way, -7, and then we have x is less than 1. Well, if we looked at just the x is less than 1, okay, that goes on forever that way. If we look at just the -7, that goes on forever that way. But what they have in common is this space between. You see that? If you draw the lines down, what they have in common is the space between. And it's really important because this is an and. So we're only looking at between -7 and 1, since that's what they both have. So if we write that in interval notation, what's that look like? How do we write the x's from -7 to 1 in interval notation? Where did we start?
Would it be 2 parentheses, right? And
Absolutely. And then what are the numbers?
would it be negative? What's the thing called?
7?
I thought 7 goes in behind. No, okay, that's going.
Yeah, remember, we're talking about x being between -7 and 1. So where does it start on this number line? Right here. Where does it start?
Starts on -7.
Where does it end?
1.
Yep, and that's your answer. Okay. So if this is what you solve for, this is where you start and this is where you end. Make sense?
Yes.
All right. Welcome to those who just came. If your full name is not listed, can you please put your full name in the chat? So that way I can send the recording to you. Okay. So let's look at the next one. The last one was an and, right? What is it when we're dealing with an absolute value that's greater than? Anyone know? What's the opposite of and? Or. Good job, Sam. And Cadence. Yeah, or. So our two equations, we have the x plus 5 is greater than 7. And then we have the x plus 5 is what? What's the other equation? And remember, it's got to be the opposite.
Less than 7.
Not 7, but -7. Good job, though. Yeah. Okay. So now it's just a matter of solving both of these inequalities for x. So starting with the left one, what do we do?
-5 on both sides.
Yep. And we know that we got to do that to this one too. So we have x is less than what? What's -7 minus 5?
It would be -12.
Yep. And then we have or x is greater than, and what's 7 minus 5?
That's 2.
2. Okay. So we have x is less than -12 or greater than 2. So if we're looking at this at the number line and we have -12 and we have 2, are these open circles or closed circles?
Open.
Absolutely. For the x less than -12, which way does it go? Left or right?
Right.
Let's think about it. So we want to go from -12 and we want to go less. What's less than -12? Which way is that? Left or right on the number line? If this is 0.
We go to the right.
Is that going to go towards larger numbers or smaller numbers?
Smaller numbers.
Is 2 larger or smaller than -12?
Oh, smaller numbers. No, the bigger numbers.
Yeah, so if we want to go less than -12, we need to go to the left. See that? So now we have x's or x is greater than 2. So starting at 2, which way do we go, left or right? If we want numbers that are greater than 2.
Go right.
Yeah. Okay. So now that we have our graph, how do we write this in interval notation, starting from left to right? Where do we start with?
The parentheses.
Okay. And
Negative
what's,
infinity.
you got it, negative infinity. Where's it stop?
-12, comma,
Parenthesis.
u,
Yep. Unioned with what?
2 to positive infinity.
You got it. And all of this is in parentheses because none of it's included. Good job. Okay, so you can kind of see the difference between these two, right? The and, notice, just like with the, I guess you could call it set builder notation, right? Is the x is between two numbers, and so our solution, our interval notation, is just two numbers. On the second one, or, we're dealing with two different equations going opposite directions, so we have to union two different sets. Let's look at this last one. So we have the absolute value of 3x minus 1 is less than negative 15. So what do we do?
Get the x by itself.
We usually would, yes, but is this possible?
No, this is absolute, huh? So you can't have a negative outcome if it's absolute, because anything absolute is going to make it a positive number.
That's right. Now, if it had said greater than negative 15, yeah, right? Because of course we're going to get something greater than negative 15. We're going to get a positive number. This is less than negative 15. It's just not possible whatsoever. And so your answer is empty set. There's nothing there. It's not possible. D&E. Good job, guys. Any questions on these? Okay. All right, let's move on to completing the square. So previously we did extraction of roots, and we even did quadratic formula. Now we're going to do completing the square. So if we're completing the square, where do we start? X squared plus 4x equals 1.
Should we try to get it to equal to 0?
We don't when we're completing the square, but that is a good guess. If we were just trying to factor it, absolutely. I will tell you, this is not factorable, and that's why we're completing the square.
Gotcha.
What I will do though, to kind of help you guys, is I will leave some space here. Okay. So remember that this side, we want to create a perfect square. So how are we going to create a perfect square? How do we find what we need to add on the left side to get a perfect square? Very good. Very good. Very good. Yeah, you take half of the middle term, which we know is b, and you square it. Good job. Yeah, so in this case, we're going to take that 4, we're going to divide it by 2, and we're going to square it. So 4 divided by 2 is 2. Okay. 2 squared is, I'm actually going to write that right here. Yep, good job. Okay, give myself a little bit more room down here. All right, so if we're adding 4 to this side, we also have to add 4 to that side. That's why I put these little placeholders here. So now we have our perfect square. Now this is factorable. What's this factor to? On this side, the x squared plus 4x plus 4. Very good, x plus 2. And it's x plus 2 squared, which is why it's a perfect square. X plus 2 times x plus 2. And then we have 1 plus 4, which is our 5. Another way you can also find out what this middle term is usually whatever you've divided by 2, this right here is the term that goes there. So that's a quick little shortcut. Okay, so now we have x plus 2 squared equals 5. How do we solve from here? What would be the opposite of squaring that x plus 2?
Square root.
Yeah, good job, guys. Okay, yeah. We're going to take the square root. So this becomes x plus 2 because the square root of anything squared is just the whatever the base is. But since we're taking the personal square root of that 5, as we stated earlier, we have 2 possibilities. So it is plus or minus the square root of 5. And if we wanted to finish solving for x, what are we going to do with that 2?
Subtract it.
You got it, subtract it. And the best way to write this would be whatever you have left over here, pop that in front of your plus or minus square root. Just because this is 2 possibilities on the side and this number is the same. And again, if you're putting this, online, your answers would be -2 plus square root 5, comma, -2 minus square root 5 as your 2 possibilities. But if you're submitting it in paper form, that's solid. Any questions about that one? We got one more completing the square we can go through together. Okay, so let's do the next one. So if we want to complete the square, this is set equal to 0. What's the first thing we've got to do if we want to start completing the square to solve this? Very good. Yes, we're going to subtract 11 because we want this to be by itself so that we can create our perfect square. So that leaves us with x squared minus 8x plus, and again, I'm just making placeholders. And this is -11. Okay. And again, how are we finding this term that we're adding to both sides? What are we doing with that -8?
Divided by 2, just squaring it.
Yep, divide by 2 and square. So -8 divided by 2 is what?
-4.
-4. And -4 squared is
16.
16. So we're going to add 16 to both sides. Okay. So what's our perfect square on this side?
X plus 4.
You're close. Megan, you did get it though. It's -4. Remember, whatever this number is, ends up being what goes here. The case for that though, if you want to know, is remember it's got to be the square root of 16, which is possibly plus or minus 4. But then it's got to add to -8. So -4 plus -4 is -8. Make sense? And then on this side, we have -11 plus 16, which is what?
5.
5. Somehow we got 5 again. Okay. And we're just taking the same steps as last time. So from here on out, what are we doing?
Square root it.
Yep, you got it. So this becomes x minus 4 equals plus or minus the square root of 5. So what's our x equal?
X equals 4 plus or minus square root of 5.
Good job. Any questions about completing the square? Usually for those of you doing your tests online, you probably will be submitting any handwritten work that you have to show. This is going to be a big one. So make sure you show your work. All right, let's move on. So in this case, we're going to find the zeros or solve, and we could do it in any way we want algebraically. So this means that we could factor if it's possible, use extracting roots if it counts for it, use quadratic formula, or even complete the square. I know usually if we see a number here that's greater than 1, we probably want to go to quadratic formula because that's kind of our best friend for everything. But I will tell you that this one in particular does factor nicely. So if we were trying to factor this one, what would our two factors be?
Four x minus 11.
Close. 4x and x, definitely. But remember, the last part is you have 3, or technically -3, right? So one of them is positive and one of them is negative, and your only factors are 3 and 1. So how can we get -11 if this is multiplied by that and this is multiplied by that? Where do we want to put our 3? Do we want to put our 3 in the first one, or do we want to put our 3 in the second one?
Second one.
Yeah. And then which one should be negative if we went -11?
The right side.
Absolutely. Because 4 times -3 is -12. And 1 times 1 is just 1. So -12 plus 1 is -11. When we're at this point, what do we do next if we're solving for x?
Create two separate problems.
Yeah.
So 4x plus 1 equals 0, then x minus 3 equals 0.
See, I'm trying to solve it already. There we go. Okay. So what do we do with the 4x plus 1 to solve for x?
was gonna let someone else answer.
So if we're trying to get x by itself when we have 4x plus 1, what do we
You
need to do
might
with?
you minus 1, then you divide by 4.
Yeah. So you have 4x equals -1. Dividing by 4, you have x equals -1/4. And then for the second one, we're just adding 3, right? To both sides.
Yep.
So you have x equals 3. You could write it like this, or you could write it as x equals -1/4, comma 3. Also correct. Right. Okay. The second one is not as kind. And again, like I said before, usually when we see numbers greater than 1 here for our A, our go-to is the quadratic formula. And you can solve this one with the quadratic formula if you like. You could have solved the first one with the quadratic formula if you liked. That's up to you. If you were given a choice to do whatever you want, definitely go with the method that calls out to you. I'm going to go ahead and say let's use the quadratic formula. And just for reference, that's this one that we did earlier. Okay, so what is our A, B, and C? What's our A?
A is 2,
Mhm.
B is -1,
Good job.
and C is -7.
You got it. Good job. So we have x equals -1 squared. Be sure you guys let me know if I mess up, okay? Because it happens. I do it. I'm human. For A is 2, C is -7. Wow, guys, that might be the straightest line I've ever drawn. And A is 2. Okay, so cleaning this up a bit, -1 is what? Oh, I did mess up though, didn't I? That's not squared. So let's try this again. -1 is what? Good job. +1. Okay. And cleaning up the inside, -1 squared. +1. And then we have -4 times 2 times -7. So what's that? -4 times 2 is you're close, Sam. Yeah. I know no one could see Megan's message, but yes. Just remember this is think of it as a -4 times 2 times -7. So -8 times -7 is +56. Although Sam, what you could have done if you are used to writing it this way is just written it as 1 minus -56. And then you still would have gotten your plus. Okay, 2 times 2. Four. Okay. Not much to this one, right? So cleaning up, 1 plus or minus square root of what? What's 1 plus 56? $57, right? All over 4. Can we reduce that at all? No. Yeah, no, we can't. Square root of 57 is just the square root of 57. So you can write this as 1 plus square root of 57 over 4, 1 minus square root of 57 over 4. That's how you'd write it if you separate it. Any questions about these two? Okay, we got a big one coming up with several parts. Yeah, this is a big one for the test. We have A through G. As you can see, we only can see A through D, so the other parts are on the next slide. So we'll just work this, and then we'll go back and refer to it as needed. So we're given the graph f of x equals negative x squared plus 2x plus 8. And you can solve all of this stuff with a graphing calculator. Absolutely. And it's a lot quicker too. But it's also good to know how to do it by hand, especially if you don't have a graphing calculator, don't have access to a graphing calculator, or you're just asked to do it by hand. So if you're asked to do it by hand and you have to use the vertex formula to find the vertex of a quadratic, let me write down the vertex formula. Does anyone here remember the vertex formula? How you'd find x? And it's totally okay if you don't know or don't remember.
Yeah, I don't. My guess is like a minus h.
That's fair. It's actually negative b over 2a. And that's for the x value. And then for the y value of the vertex, you plug that in. So if we're finding our x value, first off, what's our b, our a and our b? Should probably of this right here. What's our a? Good job, -1. And what's our b? Two. All right, so we have -2 over 2 times -1, right? Which is -2 over -2, right? Or 1. Okay. And then if we wanted to find our y value, we would plug that back in. So we'd have -1 squared plus 2 times 1 plus 8. 1 squared is 1. So this is -1 plus 2 plus 8. What's that equal? Good job, 9. So our vertex is what point?
1, 9.
Yep. So that's our vertex. What's our axis of symmetry?
That where it splits.
Yeah,
you
that's.
couldn't,
Mhm.
yeah, cut it in half.
Where do we do that?
On the x-intercept, the y in the middle, or the vertical line.
Vertical line. So x equals, and which value of the vertex? The x or the y?
The x will be flipped.
So just x equals 1, right? So you get that from the x value. Okay. If and that would be it for the axis of symmetry. So if we want to find the y-intercept, remember that the y-intercept is y comma 0. Or yeah, not y comma 0, but let me, guys. Oof, okay, let me try that again. 0 comma y. Right? Because we have our y value. We're plugging in 0 for x. So let's plug in 0 for x. You have negative 0 squared plus 2 times 0 plus 8. What's our y equal?
8,
8. So what's our y-intercept?
0, 8.
And then for zeros of the function, doing it by hand, because this is a negative right here, I would suggest moving everything to the other side. So if you have 0 equals negative x squared plus 2x plus 8, I move everything over, so it's x squared minus 2x minus 8 equals 0. Can we factor that?
Yeah,
Yeah. What are our two factors?
x minus 4, x plus 2.
You got it. And these are all equal to 0. So we have x minus 4 equals 0 and x plus 2 equals 0. So we have x equals 4 and x equals negative 2. Careful. It's asking for zeros, so this would be the answer. But if it wants the intercepts, that would be 4 comma 0 and negative 2 comma 0. Still not done with this particular one. So now we'd have to sketch the graph using the previous information. Again, what we know is that the vertex is 1, 9. The y-int is 0, 8. Our x-int are 4, 0 and negative 2, 0. And our axis of symmetry is x equals 1. So I'm going to try and draw this as straight as I can, guys. If we have our graph, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8, 9. Okay, so some of the points we have negative 2, 0, we have 4, 0, we have 0, 8, and we have 1, 9. So it's just a matter of connecting the dots. There you go. It's pretty solid, right? Again, If you're looking to solve all this, you could do all of this in the graphing calculator or on Desmos. I'll show you that in a moment. Do we have any relative maximums or minimums?
Yes.
Yeah. First off, is it a maximum or a minimum?
Max.
And what is our max?
1,9. The vertex.
So you're there. You know what you're talking about. Just remember that the maximum is the y value only.
Okay.
And we have no relative minimums. What's our domain and range of this function?
Domain. Would it be negative infinity to infinity?
Absolutely. Usually any polynomial is going to be negative infinity to infinity. What's our range?
Negative infinity to 9. Would
You
it be
got
a
it.
square bracket?
You got it. Good job. Really quick, I'm going to show you guys how we could have done all of this super quickly on Desmos. If you type in f of x equals negative x squared plus 2x plus 8, and you can use that using the keyboard down here at the bottom. So we have our vertex, we have our y-intercept, we have our zeros, we have the graph. And yeah. And if you're using a graphing calculator, your favorite button is going to be to graph it using the y equals button, typing it in, hitting graph, and then doing second calc. And you could look for maximum or minimum, or you could trace, or you could even do second y equals, and it'll give you the table of values, and you can look for the specific zeros. Lots of options, done a lot quicker than by hand. But if you're asked to do it by hand, it's possible. Any questions about this one? Because this one had a lot of different parts. Okay. Now we're dealing with a box. So we have an open box, and I'm going to go ahead and draw the open box because that always helps. And this open box, okay, it's about as good as we're going to get, guys. Is made from a 10 centimeter by 20 centimeter piece of aluminum by cutting a square in each corner and folding up the edges. So it looked like this, and this was 10, and that would, well, yeah, that was 20. And they took a square out of each corner. Okay. Cut that out and then folded it up. And it says the area is 90 square centimeters, and it wants to know the lengths of the sides. So first things to note, what is our formula for the area of a space? What's area of a rectangle? The formula.
Area equals length times width.
So we have length times width. The issue with this is that we can't just say, oh, it's 10 times 20, right? We do know that the result was 90, but what we don't know is the new length and width. What we do know is that the square that was cut out in each corner was the same length. So we could call that square, this little square right here. Let me do that a different color. So we'll say that this is an x by x square, okay? Because we don't know what it is. So we assign it a variable, which means that these are x, which means that these are x, which means that these are x. So far, so good. If we want to find let me find a good color for this. If we want to find this length right here, and we know that from here to here is 10, and that is x and that is x, how do we find this length right here? What do we have to do?
I have no idea.
Well, we know the whole length is what? 10, right? So we, whoops. We know the whole length is 10. But we want to subtract the space that we cut out. How much did we cut out? We cut out an x over here and we cut out an x over here. So how many x's did we cut out?
2.
Does that make sense?
Yeah.
So that means that this would be 10 minus 2x. Let's think the same thing for the 20 side. So if we want to find this length and the whole length is 20, but we cut out 2x, what do we have here?
20 minus 2x.
You got it. Okay. So that means that our new length and width are 10 minus 2x and 20 minus 2x. So our length and width that equal 90 are 20 minus 2x and 10 minus 2x. Okay. From here, if we want to solve this, we're going to have to combine everything first. Because what we really need to know in order to figure out the lengths is what x is. So let's FOIL. So 20 times 10.
200.
20 times negative 2x.
Negative 40x.
Negative 2x times 10.
Negative 20x.
And negative 2x times negative 2x.
4x squared.
Okay, so let's combine like terms, and I'm going to move everything in descending order. So 4x squared. Negative 20 plus negative 20 is what? Or negative 40 minus 20.
Minus 60x.
Yeah. Plus 200 equals 90. This is starting to look like something that we can solve. Yeah, it is. So now if we're looking at a quadratic, we can just move that 90 over. So we get 4x squared minus 60x, plus 110 equals 0. I'm going to tell you right now, we could reduce this. We could factor it by 2. And by factoring it by 2, we'd get 2x squared minus 30x plus 55 equals 0. Either way, this thing looks ugly. Quadratic formula is going to be your best bet here. The other thing you could do is graph it, right? Let's do quadratic formula, and then I'll show you what graphing it, how we could solve it by graphing. So x equals a, b, and c, right? What's our a here? And let's go ahead and use this one right here. So our a is 2. What's our b?
Is negative 30.
Yep. And our c is 55. So we got negative 30 plus or minus square root negative 30 squared minus 4 times a, which is 2, times c, which is 55. I'm going to bring that square root all the way up. All over 2 times 2. So we have positive 30 plus or minus square root. What is negative 30 squared? And it's okay to bust out the calculator for this stuff, guys.
900.
Yeah, 900. 4 times 2 times 55, or negative 4 times 2 times 55.
-440.
Yeah.
440.
Negative 440. And this is all over 4. Okay. So we have 30 plus or minus the square root of what? What's 900 minus 440?
460.
460. All over 4. Now, the ones we've seen before, you know, we can't do anything with them, right? But 460, we can possibly reduce that radical or simplify that radical. So I do want to show that just in case you come across something where you need to simplify the radical. If we were to simplify 460, what is the smallest perfect square that goes into that?
18.
Okay, so if we broke this down, what times what is 460? 10 and 46, right? That's a quick one. 10 and 46. What goes into here? What times what is 10?
5 and 2.
5 and 2. And for 46?
23 and 2.
Yeah. Oops. 2 times. Give me a second. This thing acted up on me. 2 times 23. So notice we have 2 2's. So we have a perfect square, which means that we have 2 squared, or 4, right? So square root of 460 equals the square root of 4 times the square root of 5 times 23, which is 115. What's the square root of 4?
2.
2, right? And we knew that already. So we have 30 plus or minus 2 root 115 over 4. Can we reduce that at all?
No.
You don't think maybe the 30, the 2, and the 4 have something in common?
I was wondering why it doesn't go over the square root,
What, the 2?
the divided by 4.
It does. I just didn't draw it long enough. It's like that.
Okay, so we can divide 2 square root by 4?
Yeah, so the way that you would do this safely so that we don't make any mistakes, and I'll do it up here, is you would rewrite it as 30 divided by 4 plus or minus 2 root 115 divided by 4. And then you can reduce these. And I believe they can both be reduced by 2. So that becomes 15 over 2 plus or minus the square root of 115 over 2. Do you guys see that?
Yeah.
Which is just 15 plus or minus the square root of 115 over 2. Now, this has 2 possible answers. We're talking about a box, and it's very possible that one of these answers doesn't work. So we test it. We test 15 plus square root of 115 over 2 and 15 minus the square root of 115 over 2. What's the approximate value of the first one? By plugging that into a calculator, by the way. What's the approximate value? If you're not sure, just plug it into your calculator. Here we have 15 plus the square root of 115. And this whole thing is divided by 2. So you have 12.8. And if we take this and we do it again, but with the minus, we have 2.1. You know, roughly rounded. Now.
Okay, I had a question. I tried to punch it in my calculator, but it's kind of hard to do the square root and the division sign at the same time.
So what you can do is you could do the 15 plus the square root of 15 first, hit enter, and then just type divide by 2, or you can do second answer to recall the answer from before and divide it by 2.
Okay.
And
Yeah, that worked. I wasn't sure. So I tried to put the square root in parentheses and I got a different answer, but the way you said it worked.
Yeah, yes. Depending on the calculator you have, you might have to take it in a couple steps, and that might be easier, and that's okay. Now, there's 2 possible answers, but what's the issue with one of these?
It's too small?
Well, 2.1, that square could fit in both the 10 side and the 20 side, right? But what about the 12.8?
It's too big.
Way too big. Right? One of our sides is only 10. If we cut out we can't cut out a 12.8 square out of that. So the sides of our square is 2.1 centimeters. Any questions about that one? And that one was a doozy. If you wanted to see it graphed, another way you could solve it would be by graphing it. 20 minus 2x, and then it was minus 90 equals 0. Okay, and as you can see, we have our quadratic graphed. It's really hard to see. You'd have to zoom out, right? But you could get a window that fits to find the maximum, or not the maximum, the zeros. And as you can see, just clicking that gives you both zeros. And we know that the 12.8 doesn't work, so it has to be the 2.1. Definitely a quicker method, but if you got to do it by hand, you know how to do it. You definitely got to know how to set it up, because if you don't set it up properly, you're not going to get it right. Okay. Any other questions on the box one? Okay. I will say drawing the diagram is what's going to help you set it up. This picture right here is your golden ticket. Okay. This is another popular question you guys are going to see on the test. A model rocket is launched with an initial velocity of 150 feet per second from a height of 40 feet. The function is a quadratic, gives the height of the rocket t seconds after it's been launched. Determine the time at which the rocket reaches its maximum height and find the maximum height. What are we looking for here with this function? What are we looking for? Definitely looking for the height. But we're dealing with a quadratic. So what point on the quadratic are we actually solving for?
The vertex.
Yeah, we are legit looking for the vertex. And that is the case with all of these. Think of it kind of like Angry Birds, right? This thing's launched from 40 feet. And we want to know the height of the rocket. So we want to know that vertex point. So a couple ways to do this, right? You can plug it into your calculator and look for the maximum, right? And that's the key here, maximum. Or we can use the vertex formula, which is the negative b over 2a, comma, f of negative b over 2a. Okay. If you have to use the vertex formula, then we have t equals negative b over 2a. And our negative b is what? What's our b?
150.
Yep, 150. What's our a?
Negative 16.
Negative 16. That makes it 150 over 32, positive, right? Which is approximately what?
5.
Probably don't want to round it up that high. I'd say it might be safe to round to 4 decimal. Unless, yeah.
It is 4.6875.
There you go. Yeah, I'd say when you see stuff like this, round to whatever it tells you. I didn't specify here. In most cases, it'll be like round to 4 decimals or round to 2 decimals. So make sure that you round to the appropriate decimal. And then the second part of that is doing S of 4.6875, right? Which is negative 16 times 4.6875 squared plus 150, 4.6875 plus 40, which is approximately what?
I'm entering it in my calculator right now.
No, you're good. I'll gladly give you the time.
I got 391. Yep, what she typed.
Good job, guys. Yeah. So the vertex itself would be the 4.6875. I want to make sure I'm writing it right. 391.5625. But our answer, because it wants to know at the time it reaches height and the height. So it reaches the max height of 391.5625 feet. Definitely don't want to forget the feet, right? At 4.6875 seconds. Don't want to forget the seconds. And that's your answer. Again, really quick way. If you bust out your calculator and we just type S of t, actually we'll say x equals, and then we have negative 16x squared plus 150x plus 40. We have our graph. Zoom out enough, click it, and there you go. This one's rounded to 3 decimal places. Again, if you're using a graphing calculator, y equals 0, type it in, hit graph, second calc, maximum, trace it to the left bounds, trace it to the right bounds, and you're going to come up with the same answer. So you don't have to put in all of that work if you know you're looking for the vertex or the maximum or minimum, right? But it's good to recognize that the vertex is the maximum or minimum. Any other questions on this one? All right, let's keep going. Hey, this sounds like our best friend already. First few words, use a graphing calculator to find the real zeros of the function and approximate answers to the nearest thousandth. Cool. I'm going to use my graphing calculator, which is this. So we have x to the 4th minus 2x minus 5.6. I'm just gonna let's see. Did I type that right? No, I forgot a cube, didn't I? I was wondering. There we go. Okay. Click this, and I have, those are my 2 zeros. So the approximates are negative 1.205 and 2.403. And I'm going to just go ahead and write that down. So x is approximately negative 1.205 and x is approximately 2.403. Again, if you graph it in your graphing calculator, you hit that y equals button. And then you can do second. You can do calc and then go to zeros. Or you can go to the table and search for when your y is equal to 0. And it should bring up both of those. But that one's pretty nice, right? Not too much work involved. Any questions on that one? Okay. Man, we're just looking out here. So we're using the graphing calculator to find the real zeros, any maximum and minimum, and the range. And we state where the function is increasing and decreasing. Okay. So again, I'm just going to bust out my calculator and I'm going to type the function f of x equals x cubed plus 2x squared minus 11x minus 12. Okay, and I'm going to zoom in so you guys can kind of see it. This is pretty much it. So loops up, comes down, loops back up, goes off forever in each direction, right? Here's our, going back to what it's asking. It wants the zeros, the maximum, the minimum, and the range. So first things first, let me go ahead and kind of graph what we're looking at here. Definitely looks like that, right? So let's see, our zeros. Well, these are nice. -4, -1, and 3. You see that? Okay. So I'm just going to come back here. I'm going to say that that's -4. I'm going to say that that's -1. And I'm going to say that that's 3. So our zeros, x equals -4, -1, and 3. We want to know our relative max and our relative min. So our max and our min. Let's take a look. Which number is our maximum?
A -2.6. That's 12.597. My bad.
Good job. Yeah, the 12.597. Yeah, the y value. And let's see, does it want us to, it doesn't say what to round it to. So I'm going to just say it's approximately 12.6. Okay. And yes, this occurs at the x equals approximately -2.7. Let's go back again. What's our min? What's our minimum?
-20.
Yeah, -20.7.
Yep.
And it occurs at x equals approximately 1.4. So -20.7 occurs at x is approximately -1.4. No, not negative, positive, right? And I'll actually put that 1.4, -20.7, and -2.7 12 point. Wow, that is not a 2. Do you guys see that? Okay, 12.6. We go. What's our range?
Is it negative infinity to 12.6?
So definitely negative infinity, right? Does it ever keep going up higher than 12.6?
Yes,
Yeah, where's it go to?
infinity.
Yeah, you got it.
Yeah, I wasn't sure if it's one of those ones where you have to like bracket and like do the union, if that makes sense.
Yeah, no, I know what you're talking about. Funny story. We're getting into that next. So now we want to know where it's increasing and decreasing.
Gotcha.
And I'm going to go ahead and just use the graph that I drew, the funky one that's obviously not really to scale, right? And anywhere it's increasing, I'm going to do a light blue because it's going up. So if it's going up, that's increasing. And if it's going down, I'm going to do my red. Okay. So with that on the graph, what are the intervals that it's increasing? Where does it start?
It is increasing from negative infinity to 2.7.
Yeah,
So we go to,
the negative 2.7.
yep,
Anywhere else?
from 1.4 to infinity.
You got it. Yeah, good job. Yeah, this is, yeah, the maximums and minimums is where all of this occurs, right? So where's it decreasing then?
I'm gonna step back, see what Megan thinks.
What do you think, Megan? Where's it decreasing? What's the interval? Where does it start from left to right? Definitely. What number? What's the X value? Good job. Negative 2.7. Where's it go till? Where's it stop decreasing? All right, that's fair. This means I get a chance to bring up something that I wanted to do. Yay. Okay, so something you can do when you're determining intervals of increase and decrease is kind of bring everything down on a number line. So if we bring this down and we treat this as negative infinity and positive infinity, let's bring down the maximums and minimums. Okay, the xi's. So this is negative, whoops. What did I do? negative 2.7. And what's the x value of this maximum? Or minimum, I should say, sorry. $1.4. And then what we do is we go along and we decide, okay, so where is it increasing and where is it decreasing? So we said that this is increasing. We said that the center is decreasing and that the end is increasing. And now we actually have an easier way of doing our interval notation. Yep, good job, 1.4. But yeah, so then it allows you to see that from negative infinity to 2.7, and from 1.4 to infinity, it's increasing, and it's decreasing from negative 2.7 to 1.4. All right, that one was a doozy, but it wasn't too bad because we got to use the calculator for everything, right? How do you guys feel about that one? Pretty good?
Do you have another one?
I don't, but I could come up with one. I don't have one on the PowerPoint, but I can gladly come up with one. Let's see, looking at what I have left. We're gonna kind of be getting into something close to that. And if you'd like, after we do that question, we can take a look at solving for like max, minimum, range, and increase and decrease. Sound good?
Yeah, sounds good to me.
All right. Okay. Yeah, no, it is a good one. And there's a lot involved. Now the next one. This one's a little tricky, not gonna lie. This, we don't know what B is. And that's what we want to find. But there's specifics to B. We have to find B such that it has a maximum value of 2. So that means whatever our B is, the maximum value has to be 2. So let's think about this. If we want to find this, we should probably use the vertex formula. And this is why it's kind of important to know it. Because what is the vertex formula? I know I've said it a few times.
B divided by 2 squared.
Yeah, you're super close. Negative B over 2A.
Yeah, and the negative B is squared. Or the no squared.
No squared. In this case, then you plug in the negative
Okay.
B over 2A into the function for your Y value, for your X and Y. Okay. And so if we're doing that, we know our A is -3, right? So negative B over 2 times -3 is what?
-6.
-6. So we have negative B over -6, which is B over 6. Right?
Yep.
Okay. And if we were plugging this in for X, so F of B over 6, right? We have -3 B over 6 squared plus B times B over 6 minus 1. So far, so good.
Yeah, I think so. Yeah, because you plugged it in into the formula.
Yeah, we just plugged it in. So if we simplify this, this is -3. This is b squared, b over 6 squared. So this is b squared over what?
36.
Yeah. And then we have plus b
B
times
squared. 6b.
over 6.
Okay,
Yeah, remember this is, think of that as like over 1
gotcha.
minus 1. Okay. Multiplying this out, can we reduce this? Whoops, did not mean to make a mark there. Just
Would 12 would be 12?
yeah, 3 definitely goes into 36. 12 times. Absolutely. So this becomes -b squared over 12 plus b squared over 6
Would it
minus
be
1.
positive? Is it positive 12 since it was a -3?
So it's a -3 times b squared over 12.
Oh, I see the b's at the top. The negative's at the top. Okay, okay.
Yeah, I just stuck it in the top because
Okay.
lazy.
No, it's all good. It's all good. I see it now.
Yeah. So in order to add these two fractions, what do we need?
Uh, Common denominators.
Yep. So what do we got to multiply this by?
That multiply that one, the one you're pointing at, by 2.
Yeah. So we have -b squared over 12 plus 2b squared over 12 minus 1. What's -b plus 2b?
B squared.
Yep. So b squared over 12 minus 1. And that's pretty much it. So our vertex here is b over 6, b squared minus 12 over 12 minus 1. So remember, our maximum is 2. And our maximum,
Equals y.
yeah, is the y value of our vertex. It's the whole reason we're doing this. So that means that b squared over 12 minus 1 equals what?
2.
Yeah. Now let's solve for b. So first thing we do.
1.
Absolutely. So b squared over 12 equals 3. Now what?
Multiply both sides by 12.
You got it. So b squared equals 36.
And then you square it, and b equals 6. Square root it.
B equals plus or minus 6.
Okay.
Yeah. And then, yeah, there you go.
So now we got b.
Now we got B. That's what we needed, right?
Yeah, so now we can put in the
Find
work.
B.
Okay, gotcha. So we don't have to worry about. I got you. Okay, I thought we still was trying to figure out the maximum value is 2. Then what is the x and the x?
Yeah, I mean, we could go that extra mile, right? But we don't need to,
Yeah, that's fine with me.
right? We did all the hard stuff. We're pretty good.
Yeah. Okay.
No.
Cool. Cool.
Yeah. So remember, if it wants you to find one of these, right, such that there's a maximum value or a minimum of something, that's our golden ticket, because that is a quadratic, which means our maximum or our minimum is our vertex. So we can use the vertex formula to solve for the missing part.
Okay.
All right. Now let's do, we've only got 3 left, so we're almost done. Now we have 9 minus x squared is less than 0. You can solve this graphically.
I would take out the less than sign, change it to equal.
Yeah, definitely, right? If you were plugging it in, it'd be what, 9 minus x squared?
Yep.
So x and y. That just means that the 9's up here, right? Nine. It comes down. Okay. What is our, and I will actually go ahead and plug it in here too. Y equals 9 minus x squared. Okay. So our zeros are 3 and -3, right?
Yep.
Which means, and I will mark that here. So -3 and 3. So where is 9 minus x squared less than 0?
Should we write it as y equals 9x minus x squared is less than 0? I guess from -3 to 9.
Close, close. So
-3 to 0.
So think of this as when it's talking about less than 0, it's talking about the
Yeah.
x-axis, right? The
Yeah.
x-axis is 0, right?
Gotcha. So negative infinity to -3.
Yeah, it's gonna be everything here. And where else will it be?
Oh, on the +3.
And down here.
Gotcha.
So
So negative infinity to -3, then 3 to infinity.
yep. And we're not going to include these numbers, even though they're zeros, because that implies it's equal to 0, and we only want what it's less than.
Yeah, we
Okay.
don't have the bottom.
So you can do open circles for that to help you.
Okay.
Yeah. Not too bad for that one, right?
Nope.
Okay. Let's look at the next one. So again, solve this graphically. X minus 1 times x plus 3. Okay. So I'm just going to type it in like that. X minus 1 times x plus 3 equals 0. Okay. We know it's a
Has to have a minimum.
it does. A minimum, or let's see. Yeah, it does. It's just really bad. Okay. Let's do equals y. I think I fixed it. There we go. Okay, so just do y equals that. Okay, so that's our minimum. So our minimum is -1, -4, and our 2 zeros are -3 and 1. Okay.
Gotcha.
So if we're gonna just graph that real quick on here. X, Y was what? -1,
-1,
-4, and -3 and 1. Okay.
-1, -4, then -3, 0, 1, 0.
Yeah, so it's like right here. -3, 1. Okay. Now, what's it asking? It's asking.
Greater than or equal to 0. So
Yes.
anything above the x-axis.
Yep. So all of this and all of this. Does it?
Including the 0.
Yeah, it includes that. So we're going to do close circles there. big one so that we know.
All right.
All right, so how do we write this interval?
The negative infinity to -3. And then union is a close bracket
Yeah.
and parentheses. No, yeah, you're right. It starts off with 1 and
Mhm.
then it goes to infinity, and that's a parentheses.
Good job. A lot easier to do this when you're graphing it, right?
Yeah, definitely.
Yeah, if you're dealing with quadratics and we're talking about less than or equal to something, definitely get it all on one side so that zero's on the other side, graph it, and you're golden. All right, and a really good example for that is right here. We don't have this less than or greater than or equal to 0, right? So let's move everything to one side.
All right, I would minus the 5x and add 6.
Absolutely. X cubed minus 2x squared minus 5x plus 6 is less than 0. Okay. And I'm just going to put that in here. So y equals x cubed minus 2x squared minus 5x
plus
plus
6.
6. Okay. And this is our graph. Here's our zeros. Yep. So -2, 1, and 3. We don't really care about where these go, but we want to know how it works. So let me go ahead and we said it was -2, 1, and 3. Okay. So -2, 1, and 3. And it goes like this. And that. And that. Not perfect, right?
Yeah. Yeah.
Not perfect, but that's okay.
But
Doesn't
it
need to
works.
be. It
Yeah,
works.
it works.
So where is this greater than or less than 0? Where's this less than 0?
Always in a few spots. So it goes from negative infinity
Mm-hmm,
to -2,
mm-hmm.
and then 1 to 3. That's it.
Yeah. So how do we write this?
Parentheses, negative infinity, comma, -2. I believe that's a bracket. That's okay.
Oh, we don't need a bracket, right? Because this is not equal.
Gotcha. Okay. Okay, that makes sense. A union, and then 1, 3.
Good job. Done. Okay. Now, if we wanted to use this one to find other things like zeros, max, min, range, domain, increase and decreasing, we can do that too, right? Really quick, again, using the graph because it's our best friend. I'm just gonna, since we got the zeros, what are our max and min roughly?
Maximum is the 8.209,
Mhm.
and the minimum is the -4.061.
Yeah, so 8.209 and -4.061, -4.061. And I'm just going to write that too. Roughly 8.209, roughly negative 4.061. We already have our zeros, right? What
Yeah.
are our zeros?
The -2, 1, and 3.
What's our range?
Our range is -infinity to infinity.
What's our domain?
Same.
Where is it increasing?
It increases from -infinity all the way up to the max. I don't know what the max is.
Yeah, let's take a look at the graph for that.
0.8.
Yeah,
Negative
so
0.8.
negative 0.0786,
Yeah.
and I'll write that negative 0.786. So negative 0.786.
And then it's also is increasing from 3 to infinity.
Ooh, careful, not 3. Where's our
The
minimum?
minimum. The minimum is the 2.12. So then it's going from 2.12 to infinity.
Good job. How about our decreasing?
From the max down to the min.
Yeah, and remember, we're always dealing with the x values.
Okay.
Okay, that would be all that extra information you needed to know.
Cool. Cool.
All right. Well, that was it. So if you don't have any other questions, thanks for coming.
Oh, there's no problem. I'm sorry if I scared off the other folks.
No, not at all. People had stuff to do, and I was aware of that. I was made aware of that at the beginning, so we are all good. And I know you personally came in late, so I will be sure to send you the recording so that you can watch the first part
Okay.
that you missed. But thank you so much for coming, and good luck on your test.
Thank you.
Have a good one.